Hi guys, I'm Shikhar Vedi and how are you? I hope you all are doing very well. And guys, today we are gonna, from which exercise we are gonna solve the sums. We are on exercise 2.1 from R.D. Sharma, right? And today we have the sums, sum number first 10th, first 11th, and sum number first 12th. Okay, we are gonna solve these three sums. First 10th, first 11th, first 12th from R.D. Sharma and exercise number 2.1. Okay, and what we have to do, we have to find the zeros of the given polynomial and we will verify the relation between the zeros and coefficients of the polynomial, right? As we have done earlier in the sums. Fine. Okay, so just I'm gonna write, okay, sum number first 10th, and that is fv is equal to v square plus 4 under root 3 v minus 15. Okay, we have to solve this sum, means we have to find the zeros of this sum, and finding zeros means we have to equate this equation to 0, means fv is equal to 0. We have to solve this equation, right? fv is equal to 0. And what is fv? V squared plus 4 under root 3v minus 15 is equal to 0, right? Okay, so how we will be using middle term splitting method. How? Let's see. We have 15. Okay, I'm just showing you here. How can we do 15? So 15, we will do the prime factorization. So this will be 3 5s are 15 and 5 1s are 5, right? But we have to get the middle term in under root 3 form, right? We have to get it under root 3 form. So can we write this 3 as under root 3 under root 3? Am I right? Okay, or we can write 15 is equal to under root 3 into under root 3 into 5. I am writing 15 is equal to under root 3 into under root 3 into 5. What we have to get? We have to get 4 under root 3. Middle term is 4 under root 3. So it means we can write it 5 under root 3 minus root 3. 5 under root 3 minus root 3, what will be the value? 4 under root 3. See? So v squared plus, on the place of 4 under root 3, we are going to write 5 under root 3 minus under root 3. Okay, on the place of 4 under root 3, we are writing 5 under root 3 minus root 3. V minus 15 is equal to 0. That's good, na? Like the way we have done. Okay, on the place of 4 under root 3, we are writing 5 under root 3 minus root 3. Now, v squared plus, we will open the bracket, 5 under root 3 v, right? 5 under root 3 v minus under root 3 v minus 15 is equal to 0. Okay, what is common in these two terms, right? V is common. So here we are going to write v plus 5 under root 3, because we have taken common, okay, from these two terms. So here what is left? Only v is left. Here what is left? Only 5 under root 3 is left. Fine. And now, what about these two terms? What about these two terms? What is common? Minus under root 3 is common. Minus under root 3 is common. Why? See, here is under root 3. And what about 15? 15 is equals to, we know, under root 3, under root 3 is also there. It means in 15, under root 3 is common. And under root 3, that's why we have taken common, right? So here, what is left? V is left, right? After that, plus. And 15, under root 3, we have taken common. So what is left? 5 under root 3 is equal to 0. Got that? Okay. And now what is common in whole? What is common in whole? V plus 5 root 3. So now we will take this common in whole. V plus 5 root 3. Okay. What is left here? Only V is left. Here what is left? Minus root 3 is equal to 0. That's okay? Fine. And now either this is equal to 0 or this is equal to 0. Fine. So I am taking v plus 5 root 2, that is equal to 0. So v plus 5 root 3 is equal to 0. That means v is equal to minus 5 under root 3. V is equal to minus 5 under root 3. Okay. And now I am taking this is equal to 0. V minus under root 3 is equal to 0. That means v is equal to root 3. V is equal to root 3. Okay. So let's assume alpha is equal to minus 5 root 3 and beta is equal to √3. So guys, हमने zeros find out कर लिए हैं. ठीक है, what are the zeros? हमने एक zero assume करा alpha, second one is beta. So alpha is equal to -5 √3 and beta is equal to √3. That's clear. अब हमारा next step क्या है? What is the next step? You know very well. Alpha plus beta we are gonna find out, and alpha into beta. Okay. So let's see. Alpha plus beta we are going to find out now. Alpha plus beta. What is the value of alpha? -5 √3. -5 √3 plus beta. What is the value of beta? √3. So -5 √3 plus √3. Opposite signs are there. So opposite signs get subtracted. So -5 √3 plus √3, that means -4 √3. ठीक है ना? ये क्या है? -4 √3. Okay, so this is the value of alpha plus beta. And now what about alpha into beta? Alpha into beta. Alpha is -5 √3 -5 √3 into beta. Beta is √3. So √3 into √3, √3 into √3, that is 3. 3 into 5, 15. Minus sign is there, so we will write -15. Okay. Now what's the next step? We will just now check the values in the terms of coefficients. So now minus coefficient of x upon coefficient of x square. Okay. So check, here is a polynomial. Our polynomial is this. So minus coefficient of x. X means in this question we will take minus coefficient of v, right? Because we have our polynomial, it is there in the variable v. So we will write minus coefficient of v upon coefficient of v square. So coefficient of v, this is 4 √3 and minus is there, -4 √3. Okay, upon coefficient of v square. What is the coefficient of v square? 1. So -4 √3 upon 1, that means -4 √3. Okay, and the value of alpha plus beta, that is also -4 √3. So we concluded alpha plus beta is equal to minus coefficient of v upon coefficient of v square. So here we are going to write this thing. Alpha plus beta is equal to minus, okay, coefficient of v upon coefficient of v square, right? Okay, and now we will take the value constant term. We will check for the value constant term upon coefficient of v square, right? So what is the constant term? Just check out. This is -15. So -15 upon coefficient of v square. What is the coefficient of v square? That is 1. So -15 upon 1, that means -15. And alpha into beta, we already have -15. So we just verified the relation. Alpha into beta is equal to constant term upon coefficient of v square. Here we will write this. Alpha into beta is equal to, what will you write? Constant term, okay? Constant term upon coefficient of v square. Upon coefficient of v square. That's it, okay? So we just calculate the zeros of the polynomial and we verified the relation. And now question number 11th, okay? Yeah. So I need to rub it. I need to rub the whiteboard. 11th. I hope that you all are understanding these all sums very well. Okay. So first 10 just we have done. And now we are on 11th. 11th. This is py. Okay, this polynomial we have in the variable y. Py is equal to y square plus 3 √5 by 2 y minus 5. This is the given polynomial. Okay, this is the given polynomial and we have to find the zeros first. Okay, so what we will do? We will just equate this polynomial to 0 and we will be solving the polynomial equation py is equal to 0. Py is equal to 0. यही करते हैं ना हम. पॉलिनोमियल इक्वेशन को इक्वेट करते हैं जीरो से और फिर उसे सॉल्व करते हैं और हमें क्या मिलता है, जीरोस मिल जाते हैं पॉलिनोमियल पे. सो पी वाई इज इक्वल टू जीरो. व्हाट इज पी वाई? वाई स्क्वायर प्लस 3 अंडर रूट 5 upon 2y minus 5 is equal to 0. Okay, let's take the LCM here. Okay, because we have in fraction forms. Okay, we have the terms in fraction form. So we will take the LCM. Now 2, here it will be 2y square plus 3 under root 5y minus 10 is equal to 0. Am I right? Now what we will do? We will do the cross multiplication. Okay, so what we will get? 2y square plus 3 under root 5y minus 10 is equal to 0. Right? Okay. So we have to find the zeros of this polynomial. So let's solve. Right? So which method we are going to adopt? Middle term splitting method. It means we will multiply this 2 and 10. 2 tens are 20. Okay, 20. I'm showing you here. 20. And we will do the prime factorization. 2 tens are 20, 2 5s are 10, 5 ones are 5. Okay, so it means we can write 20 is equal to 2 into 5. Okay, but we have to get the middle term in the in the terms of under root 5. No problem. So we will write 2 into 5. We can write under root 5 into under root 5. Under root 5 into under root 5. Okay, so we have to get 3 under root 5. Okay, middle term we have to get 3 under root 5. So that means, yes, 4 under root 5 minus root 5. Am I right? 4 under root 5 minus root 5, that will be equal to 3 under root 5. Okay, we got it. So 2y square plus, on the place of 3 under root 5, we will write 4 under root 5 minus root 5, bracket closed, y minus 10 is equal to 0. Right? What I have done? On the place of 3 under root 5, I have written 4 under root 5 minus root 5. Okay. Now we are going to open the bracket. 2y square plus 4 under root 5y minus under root 5y minus 10 is equal to 0. Okay. Now from these two terms, we will take something common. What is common actually? 2y is common. Am I right? 2y is common. So what will be left here? Only y. What will be left here? 2 under root 5. Okay. 2 under root 5. And now here, what is common? Minus is common and under root 5 is common. Okay, minus and minus under root 5 I am taking common. So what is left here? Only y. And what is left here? Here is left 2 under root 5. 2 under root 5. How? See? Yeah, 10 is there, not 10. How you can write the 10? Then you can write 2 into under root 5 into under root 5. You can write it. And from 10 we have taken under root 5 common. Under root 5 we have taken common. So what is left? Only 2 under root 5 is left. That's why I have written here 2 under root 5. Am I right? Okay. And now what is common in whole? What is common in whole? Y plus 2 under root 5. This is common in whole. Okay. So y plus 2 under root 5. And here what is left? Only 2y. Here what is left? Minus under root 5 is equal to 0. Right? Is equal to 0. So now, you know very well, either this is equal to 0 or this is equal to 0. Right? So first we are taking y plus 2 under root 5. Y plus 2 under root 5, this is equal to 0. Y plus 2 under root 5, this is equal to 0. So that means y is equal to minus 2 under root 5. That's okay? And now this is equal to 0. 2y minus root 5 is equal to 0. 2y minus under root 5 is equal to 0. That means 2y is equal to under root 5. That means y is equal to under root 5 by 2. Under root 5 by 2. Is that okay? So now let's assume, let alpha is equal to minus 2 root 5. This one, alpha is equal to minus 2 root 5 and beta is equal to under root 5 by 2. Okay, so we have calculated the zeros of the polynomial and now we have to verify the relation between the zeros and coefficients of this polynomial. So steps, you know, what step we are going to do now? Alpha plus beta. So alpha plus beta. This is equal to minus 2 under root 5 plus under root 5 upon 2. Am I right? Now take here 1. Take the LCM 2. This will be minus 4 under root 5 plus under root 5. Is that okay? Minus 4 under root 5 plus root 5. This will be minus 3 under root 5 upon 2. Okay. So this is the value of alpha plus beta. And now alpha into beta. So alpha is minus 2 under root 5. And beta is under root 5 upon 2. Okay. Under root 5 upon 2. 2 and 2 have got cancelled. Root 5 into root 5. That is 5. Minus is also there. So we will write minus 5. So alpha into beta we have calculated minus 5. And now in the terms of coefficients we will check the value. Yeah. Minus coefficient of x upon coefficient of, and on the place of x what will you write? Y, because we have the polynomial in the terms of y. So we will write minus coefficient of y upon coefficient of y square. So what is the coefficient of y? Okay, what is the coefficient of y? We will be checking from here. See, this is our coefficient of y, right? This is our coefficient of y. This is 3 under root 5. And minus is there, minus 3 under root 5, okay, upon coefficient of y square. What is the coefficient of y square? This is 2. So, minus 3 under root 5 by 2. Minus 3 under root 5 by 2. So, and just see, check guys, alpha plus beta, that is also equal to minus 3 under root 5 by 2. So, we got the relation alpha plus beta is equal to minus coefficient of y upon coefficient of y square. We will be writing this alpha plus beta is equal to minus coefficient of y upon coefficient of y square, right? And now constant term we will be checking in the terms of constant term. So that will be constant term upon coefficient of y square. So what is the constant term? Constant term is minus 10. Minus 10. Right? And coefficient of y square, that is 2. So minus 10 by 2, that is minus 5. Minus 10 by 2, that is equal to minus 5. And just see, alpha into beta, that is also equal to minus 5. So what we concluded? We concluded alpha into beta is equal to constant term upon coefficient of y square. Okay, alpha into beta is equal to constant term upon coefficient of y square. We got this relationship. So what we have done, we just got the zeros of the polynomial and we verified the relation. That's okay? Any doubt? I don't think so any doubt is here. Fine guys. So this was our sum number first 11th. Now we will take sum number first 12th. Very hot today. First 12th. First 12th. Yeah. It's also going to be very interesting sum. Sum number first 12. What is that? First 12. This is QY. This is QY is equal to 7y square minus 11 by 3y minus 2 by 3. This is our polynomial. We have to find out the zeros. So just equate it to 0. We know this. QY is equal to 0. That means 7y square minus 11 by 3y minus 2 by 3 is equal to 0. So some of the terms are there in the fraction form. So we will take the LCM. So here is 1. Just take the LCM. It will be 3. So now 21y square minus 11y minus 2 is equal to 0. Now cross multiplication we will do. So we have 21y square minus 11y minus 2 is equal to 0. Right? So this polynomial is looking, very simple and beautiful too, right? It is in standard form. So this is our main polynomial now, right? This is our main polynomial because we have just converted this polynomial in simplest form. So this is our polynomial now. Okay, fine. So we have to find out the zeros. Just apply the middle term method, middle term splitting method. So guys, 21 into 2, that is 42. Okay, 42. And 42 we have to break this way so that we can get 11. So what can we do? 42 we have to break this way so that we can get 11. Just do the prime factorization. 42, 3 to the 4, 2 ones are 2, 3 7s are 21, 7 ones are 7. 11 we have to get, right? 11. So 7 2s are 14, 14 minus 3. 14 minus 3, 11, and 14 3s are 42. Good. So we can do, on the place of 11, we will write 14 minus 3. Okay? And 14 3s are 42. On the place of 11, we are writing 14 minus 3. Okay? 14 minus 3, y minus 2 is equal to 0. Now we will open the bracket. 21y squared minus 14y plus 3y minus 2 is equal to 0. In these two terms, what is common? 7y is common. Okay? So here is, what is left here? 3y minus 2. Okay, this is left here. And now here what is common? Nothing is common. It means we will take 1 as a common. 1, 3y minus 2 is equal to 0. And what is common in whole? 3y minus 2. This is common in whole. So what is left here? Only 7y. Only 7y is left. Right? Here. And what is left here? Only 1 is left. Fine? Only 1 is left. So, plus 1. That equals to 0. So now either this is equal to 0 or this is equal to 0. First I am taking this is equal to 0. 3y minus 2 is equal to 0. So if 3y minus 2 is equal to 0, so that means 3y is equal to 2 and y is equal to 2 by 3. Okay, we got the value y is equal to 2 by 3. And now I am taking 7y plus 1 is equal to 0. So 7y is equal to minus 1, y is equal to minus 1 by 7. We have got two different values for the y. So now we will assume let alpha. Okay, tell me what is alpha? Alpha is 2 by 3. Let alpha is equal to 2 by 3 and beta is equal to minus 1 by 7. Beta is equal to minus 1 by 7. Our next step is to calculate alpha plus beta and alpha into beta. So alpha plus beta is equal to, this is 2 by 3 minus 1 by 7. Is that okay? Now just take the LCM. 21 and this will be 14. If I am not doing any mistake. Yeah. And this is 11 by 21. This is the value of alpha plus beta. Now we are going to calculate alpha into beta. Alpha into beta. So alpha is 2 by 3. Beta is minus 1 by 7 into minus 1 by 7. So this is minus 2 upon 21. This is the value of alpha into beta. Now just calculate in the terms of coefficients. Okay. So minus coefficient of x. X or y? What? Y. Because we have the polynomial in the terms of y. In the variable y. Right. So minus coefficient of y upon coefficient of y square. So what is the coefficient of y? Yes, this is our main polynomial, na? Simplest form of polynomial. So what is the coefficient of y? This is minus 11 and we already have minus. So minus minus plus, right? Minus minus plus. Coefficient of y square. This is 21. 11 by 21. Okay. And alpha plus beta we had already calculated. This is also 11 by 21. So we concluded alpha plus beta. What is the relation? What relation we are going to verify? Alpha plus beta is equal to minus coefficient of y upon coefficient of y square. Is that okay? We verified the relation. Now we will check in the terms of constant term, right? That one. Constant term upon coefficient of y square upon coefficient of y square. So constant term. What is our constant term? This is minus 2. Minus 2 upon coefficient of y square. That what is the coefficient of y square? This is 21. Okay, so this is minus 2 by 21. And value of alpha into beta? Value of alpha into beta? Already we have calculated. Minus 2 upon 21. Same values. So we verified the relation. Alpha into beta is equal to constant term upon coefficient of y square. This we will write. Alpha into beta is equal to constant term, okay, constant term upon coefficient of y square, right? We verified the relation. So we have solved sum number first 10, first 11 and first 12. Okay guys, so इन सम्स को आप फिर से प्रैक्टिस करना. कोई लाइक आपको प्रॉब्लम होता है, कंफ्यूजन होता है, आप मुझे कमेंट बॉक्स में लिखकर बताना. आई विल सॉल्व योर प्रॉब्लम. वीडियो अच्छा लगा हो तो इसे लाइक करना, फ्रेंड्स के साथ शेयर करना और मेरे चैनल को सब्सक्राइब कर लेना. फाइन गाइस, बाय बाय.